Hello and welcome to our lesson on solving systems of linear equations in two variables. These are application problems, okay? So AKA word problems. And before I jump into the meat and potatoes of the lesson, I want you to understand that we're going to focus on how to set these up, okay? The main goal is practicing setting up the system of equations. As far as solving them, we're going to let the Casio FX991EX class whiz do the heavy lifting there. If you need to solve these by hand, you can refer back to my lesson on solving systems of linear equations in two variables. Okay, so I've got 4 examples to get through. Each one I think is a different representation of how word problems can be set up. And I'm going to try to demonstrate techniques to make it a little bit easier. For our first example, number 9, we have an etch cleaning graphics that uses one cleanser that is 25% acid and a second that is 50% acid. What they want me to do is mix these together. It says how many liters of each should be mixed in order to get 10 liters of a solution that is 40%. So here the key word is mixed. Anytime that you're doing a mixture problem, the technique I use is, well, I draw buckets. So just pretend like if you're mixing stuff together, you're going to have one bucket added to another bucket. You're mixing some of those together to equal a result bucket. In each bucket, you're going to have two numbers, a percent and an amount. So in our first bucket, it says that we have a cleanser that is 25% acid. So we're going to put the 25% in the first bucket. And the second one is 50% acid. So you can see we're putting our percents in the top of the buckets. So the result would be 40%. It says should be mixed together, that is 40% acid. Now for the amounts, we know that we want to get 10 liters of the solution. So 10 liters is what we want to end up with. So we need to know how many liters of each should I put in there to get 10 liters. And the answer is, well, I don't know. So in the first bucket, since that's my first unknown, I'm going to say I have no idea. I'm going to let that be a variable, x. And as soon as I let this be x, then I'm going to know what this one is, right? Because they have to equal 10 liters. So it could be 5 plus 5 to make 10, or 7 plus 3, or 3 plus 7. Do you see that the 2 liters in each bucket, whatever they are, they have to make 10? So what I'm going to do is I'm going to say that the 50% amount is going to be the remaining amount. So however much I use of the 25%, the rest of it has to be 50%. The way we write the rest of it is we say 10 minus x. Okay, so now check this out. If this one was 3, this one would have to be 10 minus 3, which is 7. 7 and 3 is 10. Do you get an idea now why this is 10 minus x? That's how you represent the remaining amount. Once you've populated your buckets with a percent and an amount, then you can get your equation. The way you get the equation is you simply multiply down in your buckets. So 25 times x, that's going to give us 25x. Now this is a binomial, so the 50 is going to have to distribute. 50 times 10 is 500. 50 times x, 50x. And 40 times 10 is 400. And once you get this equation, you're going to notice real quick that this is not a system of equations. This is just one linear equation with x as the variable, and we can solve for x. You could set this up with x and y, and then have a system of equations. But in my opinion, this is going to be easier. Using this technique to avoid a system of equations is, in my opinion, faster and easier. And so we will go ahead and solve this manually. 25 minus 50, that's going to be negative 25x. The 500 is going to move over, making it minus 500. And that's going to equal negative 100. And last but not least, if we divide both sides by negative 25, we can see that x is 4, positive 4. Now, what does that represent? You need to identify that amount, okay? So that means 4 liters of the 25%, right? If you're doing this for your boss and he says, how many liters of the 25% should we use? You can come back and say, well, we need to use 4 liters of the 25%. And of course, that means that you also need to use 6 liters of the 50% because they had to add up to make 10 liters. 6 and 4 is 10. So that's 6 liters of the 50%. And that's going to do it for that particular problem. That's how you do a mixture problem. Next, number 11, this time we have Tara's website. Specializes in the sale of rare or unusual vegetable seeds. All of that's irrelevant. Tara sells packets of sweet pepper seeds. Okay, let's make a note of that. Sweet pepper seeds for $2.85 each, and hot pepper seeds for $4.29 each. She also offers a 16-packet mixture, and that assortment combining packets of both seeds, so we have some sweet and some hot in there, at $3.30 per packet. How many packages of each type of seed are in the assortment? So, in order to set this up, this is going to require a system of linear equations. You're going to need to assign variables first. So we need to assign a variable that represents the number of packets of sweet pepper seeds. How about x? X is going to be sweet pepper seeds. Sweet pepper seeds. And y, let's go ahead and let y be hot pepper seeds. So then at the end, when I know x and y, I'll know which one they represent. So the first thing I know is if you mix these together, the mixture has 16 packets. So our first equation is going to be x plus y equals 16. The number of packets of sweet pepper seeds plus the number of packets of hot pepper seeds has got to equal to 16 because there's 16 packets in the assortment. The next equation is going to be the money equation. So how much do sweet pepper seeds cost? Well, they were $2.85 each. So we're going to multiply $2.85 times x, and what that'll give us the amount of money from sweet pepper seeds. And then how much were hot pepper seeds? Well, hot pepper seeds were $4.29 per packet. So we're going to say plus 429 times y. And what that represents, that's the amount of money from hot pepper seeds. And if I add the total amounts together, that should represent the total amount of money from the mixture. If you're following along with what's going on here, this is a dollar amount times the amount of packets. This is a dollar amount times an amount of packets. And so over here, we're going to have the same thing, a dollar amount times the amount of packets. And the dollar amount for the mixture, it's $3.30 per packet. And the number of packets is not an unknown. I know that is 16. the number of packets in the mixture, there's 16 packets. And so there's our second equation set up, and then we need to simplify that. So that's going to be 285x plus 429y equals whatever 3.3 times 16 is. And that is a great time to pull up the Casio and do that multiplication. Whoops, it's going to give us an improper fraction. So if I hit the SD button, that's going to be 52.8. All right, so let's outline these. These are our two equations now. And from those two equations, you can either solve this system by the addition method, you can solve by substitution, or you can solve with the class whiz, which is what I'm going to do. So with the class whiz, one more time, how to solve a system of equations. That's going to be menu, choose the equation/function app, and we're doing systems of equations. That's number one. How many unknowns? Well, there's x and y, so there's two unknowns. And the coefficients of the first equation are 1, 1, and 16. 1, 1, 16. And for the second equation, the coefficients are 2.85, 4.29, and the constant 52.8. At this point, you should see how freaking nice the class whiz is, that you can input those decimal values, and then if I hit equal one more time, it's going to tell me x is 11. Now, what did x represent? That's the number of sweet pepper seeds. And if I hit equals again, it's going to tell me how many packets of hot pepper seeds. So that's 11 and 5. It's going to take 11 packets of sweet pepper seeds and 5 packets of hot pepper seeds. All right, next example, number 17. William opened 2 investment accounts for his daughter's college fund. The first year, these investments, which totaled $3,200, that's important, yielded $155 in simple interest. Now that means you're going to need to know the formula for simple interest. Let's go ahead and write that down. Interest is principal times rate times time. That is the formula for simple interest. Part of the money was invested at 5.5%. That's 5.5%. And the rest was invested at 4%. They want to know how much was invested at each rate. So the first thing we need to do is we need to assign variables for the amount of money invested at each rate. Let's say that X is the amount of money at 5.5% and Y is the amount at 4%. And I can't stress enough how important it is to label your variables at the very beginning before you set up your problem. Now then, we know that some of the money was invested at 5.5% and the rest was at 4%. So our first equation is going to be x plus y equals 3,200, right? He had a total amount of $3,200. Some of it was at 5.5% and the rest at 4%. So if I add those amounts together, it's got to equal 3,200. Next, we have the percent equation, or you could call it the interest equation. So how do we calculate the interest at 5.5%? Well, the formula says principal times rate times time. So the principal, the amount of money at 5.5%, we don't know, that's X. The rate was 5.5%. Now, if you just plug in 5.5, that's going to be incorrect because in order to work with a percentage, you have to convert it to a decimal. So to convert a percent to a decimal, you simply move that decimal 2 to the left. 0.055 would be the interest rate as a decimal. And then the amount of time, it says the first year. The first year, that means that they've only been earning interest for 1 year. So what does all of this represent? This is the amount of interest earned from the first investment. Now we need to say plus, and we need to calculate the interest at 4%. So how much money was invested at 4%? Well, I don't know. We assigned it as Y. The interest rate, 4% as a decimal, would be 0.04. Remember, you have to move that decimal 2 to the left. And the amount of time, again, is 1. So principal times rate times time gives the amount of interest. Now, what does it equal? It should equal to the total interest earned, which was $155. The two investments together yielded $155. And so there's our second equation that we do need to simplify. And so that's going to simplify as 0.055x plus 0.04y equals 155. And then if I put a box around those two equations, those are the two equations that you would use with either the addition method or the substitution method if you have to solve manually. Again, we're going to solve it electronically with the ClassWiz. So if I clear and clear again, we're going to start over again with the ClassWiz. That's 1, 1, 3200, and 0.055, 0.04, and 155. So the amount of money invested at 5.5% was $1,800. And the amount of money invested at 4% was $1,400. So let's make a note of that, okay? $1,800 was invested at 5.5%, and $1,400 at 4% is the way you would write those answers. And you can check real quick if you want to by adding those amounts together to make sure that they equal the 3,200 that they were supposed to. And for our last example in this lesson, number 23, canoeing. Darren paddled for 4 hours with a 6 km/h current to reach a campsite. The return trip against the same current took 10 hours. Find the speed of Darren's canoe in still water. What does that mean, in still water? Well, it means how fast can Darren paddle the canoe out on the lake if there's no current? That's what that means. This particular example is a travel problem. Anything that involves travel, canoeing, driving a car, flying a plane, you're going to use a specific technique that I'm about to show you to set up these travel problems. You've got two trips, one going and one coming, or in this case, you've got the trip upstream and the trip downstream. And so we're going to label those upstream and downstream. And we're going to draw a couple of bars here and section that off. And then up on the top, you've got the formula. And the formula for travel problems is distance equals rate times time. And then we've created this little like Excel spreadsheet, this grid that we're going to fill in. And once you get all 6 boxes populated, you're going to be able to write your equations. So let's start filling in the boxes. Darren paddled for 4 hours with a 6 kilometer per hour current. Now, if he's going with the current, that's actually going to be downstream. So, how long did he paddle? He paddled for 4 hours. That's the time. And if he's paddling with the current, then the speed that he can paddle the boat, like out on the lake, is going to be increased by the amount of current. So the way we write his rate is we say X, which is the speed that he can paddle, like on the lake, which I don't know. I don't know how fast he can paddle, but it's X, and it's going to be increased by the speed of the current. So that's his total rate that he can paddle downstream. Upstream, let's do up in green. Upstream, it says the return trip against the current took 10 hours. So that's going to be the time. And if he's paddling upstream, the speed that he can paddle the canoe is going to be decreased by the speed of the current. So there's the rate and time for the upstream trip. Notice the boxes I don't have are the distance. But what I do know is that he went as far downstream as he did upstream. And so then what I can do is I can set that equal to another variable. I don't know how far he paddled, but if I assign that a variable y, then the other distance has to be the same. Because he went as far downstream as he did upstream, those will be the same variable. And so now that I have all 6 boxes populated, I can set up my equations based on the formula distance equals rate times time. That's going to be distance equals rate times time. And for the trip downstream, the equation is going to be y equals x plus 6 times 4. Now, if I'm going to solve this system with the Casio ClassWiz, these equations need to be in standard form, which would require some work, which I'm not going to do. So I'm going to solve this manually. In my opinion, it's going to be a little bit easier to just go ahead and work this out. And here's why. Notice that both of these equations are equal to y. So y definitely equals itself. Y equals y. Therefore, these have to equal. And so I can set up an equation that states x minus 6 times 10 has to equal x plus 6 times 4. And then I can solve for x pretty easily. Doing the distributive property, that's going to give us 10x minus 60. On the other side is going to give us 4x plus 24. And then if I move the 4x this way and the minus 60 this way, that's going to give us 10x minus 4x equals 60 plus 24. And then doing a little CLT, a little combined like terms, we're going to get 6x equals 84. Last step, divide both sides by 6. And 84 divided by 6 is 14. So x is 14. Now, what did x represent? If we scroll back up, we can see that x represented the speed of the canoe in still water. That's what we designated x to be. And so if they ask us to find the speed of the canoe in still water, we're done. The speed is in kilometers per hour. So we can say the speed of the canoe was 14 kilometers per hour. Now, let's play the what if game. Let's scroll back up. And instead of find the speed of the canoe, let's say, what if they had asked for the distance that he paddled to the campsite? We can actually find that amount if we know the value of x, okay? So remember, y represented the distance that he traveled to the campsite and back. So if I know x, I can calculate y by taking that back and plugging it in here or here. Either one of those will produce the distance he traveled. And so since this is green, I'm going to go ahead and plug back into the green equation. I don't know, just because. And we're going to show you how to calculate the distance he traveled, just in case you need it. So that distance would be x, which was 14, minus 6 times 10. So 14 minus 6, that is 8. 8 times 10 is 80. And that units would be kilometers. That would be the distance that he canoed to the campsite. So that covers the bases there, whether you need to know the speed or the distance. Now you know how to get either one of those. And it is very important when you're working a word problem like these that you make sure that you answer the question they ask. Once you get your final answer, you make sure that it is what they ask for. And that's going to do it for this particular lesson. So if you have any questions or comments about anything that I've covered, feel free to leave those in the comment section below, or you can text me. And thanks for watching.